With Christopher, they're going to do a demonstration of Pronghorn. Go ahead, guys.
Appreciate it. So we have 25 minutes. So we're going to skip some of the typical demo stuff we do around service models. We've talked a lot about service models this week. We've talked about CI/CD. We've talked about standard. We talked about common. I brought it up in the previous discussion. So table stakes are ingesting Yang from service models. If we have time, we've put it at the end, so we'll make it. I'm guessing we're not going to make it in the 25 minutes. So we're going to start from kind of the bottoms up. And basically, the theme for these first couple demos is just sometimes we can use the device models. If I think back to the early demos I got from the TailF folks, the first thing we always did was we logged in, we made a modification to the device model and watched that propagate through the NED down to the device. And a lot of times we take a pretty big hammer with service models for some automation decisions. So we're going to talk about the multiple ways that we can leverage NSO to basically achieve automation outcomes. So the way we think about devices is we think of network elements as code. I think this is extremely helpful as we look at config. The two blue boxes are basically what we think of as the device. So that's the device models. We get that for free with the NEDs. The next level up is device templates, and we'll see in the demo that's really day 1, day 0 configs that we talk about golden config. And then the services on top, and we really think of those services split into 2 buckets. So what we've talked about mostly over the last 2 days is really service lifecycle. That's the most valuable aspect of creating a service model in NSO. You do the create and you get the rest for free, as we've all heard. But there are definitely aspects of fire and forget that we think are useful. And basically, we want to capture this so we can get 100% of network changes going through NSO. We've talked a lot about this week going through the service orchestration framework. But what I hear in some of the sessions is that NSO falls out of sync because I can't lock people out of the CLI. So sometimes we want to follow this very regimented service orchestration process. Meanwhile, there's still network engineers in the field that have to get work done. So that's break fix, that's maintenance windows, and our devices fall out of sync. We have to do a sync from. And what we want to talk about today is really moving those users on top of NSO. And how can we achieve that outside of the traditional service orchestration framework. So when we talk about service order management, we're going to leave that off for the first part because we've talked about it a lot this week. But these fire and forget services, we can do this directly against the device model. And we can also do maintenance activities against the device models. And we can also auto-generate device templates in NSO to achieve this. So that's what we're going to do within the demo. And ultimately, the goal, because I'm going through this fast because I want to get to the demo, is the underlying portion. We really want to leverage NSO for all the changes in the network. And we really need to achieve this if we want to stop doing sync froms and stop having multiple people on the CLI. Limit the device CLI, always having NSO in sync with the network, and not doing sync froms. Because ultimately, we want NSO to be a software representation of the network, not treat it as an activation platform, as Stefan said in the earlier session, not treat it like a historical activation platform. So last slide before we get into the demo, but we do have an LSA architecture set up within the demo. So the way I'm not going to get into a bunch of the architecture with Pronghorn, but one of the big benefits outside of the 3 topics we talk about up top is the API broker. What that allows you to do is plug in as many NSOs as you want. This goes to any of our adapters. And basically, our NSO adapter uses the netconf interface to interrogate NSO and find out what devices, what services exist, and register those with Pronghorn so that we will route the calls to the appropriate place. So if you think about virtualization, you're going to spin up devices. They're going to show up within ESC. They're going to show up within the device framework of this NSO. We'll discover that and route that call to the appropriate place. So the overhead and the administration of supporting complex NSO architectures disappears. The byproduct of that, just to give you a little bit, so when Mike's clicking around, anytime we're manipulating the devices, we're routing those calls directly to the RFS nodes. And when we're doing service manipulation, it's going to the service node so that we can basically skip some of the IPC channel between the LSA architecture and to optimize each of those resources for what they can achieve. So maybe with that, we'll go ahead and get into the demo. Any questions while he's flipping over? All right.
All right, so I'm here logged into Pronghorn. And of course, depending on my RBAC capabilities, I'm going to have different icons available to me, as well as depending on what is installed in my platform. Jumping into the system page, you can see the different applications that we have here. And more importantly for this demo, we've got our CFS node in this LSA architecture, as well as our RFS, Atlanta, and Paris nodes. So jumping into device management, this does a pull into each of the adapters that are connecting into the different nodes. Of course, from the RFSs, we're finding the devices. And then from the CFS, we see the RFS that it manages. And then from this page, we can do some basic capabilities, such as take backups of devices, pull the configuration and such. And this is federated data from NSO, so at no point in here are we caching any of this. We do lots of little real-time calls out to NSO, out to our adapters, and gather the data as needed. I'm going to start with golden configuration. Pull up a configuration tree. And two of the main use cases for this application are one, device onboarding. So we can take an initial device, take it and apply a day 0, day 1 configuration here. Or the other main use case is for reconciliation. So once that device is on board with us, we're able to continually make sure that the device is in proper compliance with the model we've defined. Inside here, we're looking at the tree I've defined. I've built out a regional-based tree. It's an inheritance model, so as you get lower within the tree, you're able to pull out configuration from your node as well as the parent's node and so on. This can also be done, a lot of customers do this role-based as well, but it's really up to whoever is designing the tree on how they want to inherit the configuration. I'm going to click into the USA node here. And inside here, what we're looking at is a representation of the configuration in a kind of Yang JSON model. So the way this configuration was entered here was earlier, I clicked on the Add Configuration screen. I pasted in native configuration, and we've piped that into NSO. Using the NED, we validate the configuration, and the NED converts it into a Yang format for us, and we're able to build this model on top that we can then do different things, such as set some regular expressions on how the configuration should be, or perform negative cases to define our golden configuration. Clicking on compliance, I can see the devices that I've associated to this node. And then at any time, I'm able to go ahead and run the compliance here. And keep in mind, as I click through different areas within Pronghorn, all of these are available from our API. So whether a user's building a workflow around it or they're coming in from another system, these calls can all be done externally. So looking at this node here, the CSR New York, if I click into it, I can see the issues with it. So based on the template that you saw earlier with the configuration, we've got a list of errors. And in here, we support different conditions, such as required conditions that must be updated, as well as defined errors, informational and warning types. So depending on the condition type, you may decide to remediate it right away, or it may be something you want to push off to a workflow to get your operational models associated with that configuration. I'm going to go ahead and select them all. So on a device turnup, you can imagine that when we do push this in, we're going to get a lot of configuration diffs, because it's going to apply the initial day 1 configuration. Go ahead and hit fix there. And what this is doing is it's sending it back to NSO in the proper payload using the netconf API. And at that point, it's accepted the configuration, and I'll rerun the compliance report and should clear out the errors. So we're going to pop into an NCS CLI. Let me just grab that real quick. Got our CFS London here, Atlanta, and Paris. So I believe that one is part of this RFS node. So if I go into show commit changes, I should see that passed in there. And on the background screen there, you can see we've made it to 100%. So the next thing I'm going to demo is I'm going to go into Smart Template.
Just to interject while you're going through there. So if you think about the drawing we had up before, we had the device model at the bottom, we had device templates on top. We were basically using that golden config to push up the standard day 1 template. When we talk about smart templates, we start thinking about some fire and forget services. So these are things that the user chose to not manage the lifecycle of. So these are going to use similar technology basically to convert CLI into Yang and to push that against the device. But we're not going to be running compliance on this, so that you can imagine during maintenance windows, swinging traffic, bleeding off stuff, setting temporary variables during upgrades, those types of things. This can be very useful.
So in here to that point, if I click on this initial one here, base iOS interfaces, you can set this to some different values of configuration. Again, it's back to the native configuration, still leveraging NSO, using the NED, making sure it's valid. So in here I've got a list of configuration interfaces with sub-interfaces. For this demo, I'm going to use an SNMP community string. If I go in here, simple line here just to show the purpose of it. So this one in here is just updating it to a public. I'll leave that alone as is. And I'll go ahead and push that down. If I click apply, it brings up a form here. I'll pass in the device. I'll send that down. Looks like it's been updated. I'll pop in here. We can see the change was made via netconf. We can see the change has been applied. So this was done using the netconf API, writing directly to the device model. What we can also do is push this down as a template to NSO. So right now there's no templates on that node. But what I'll go ahead and do, first I'll make it a variable for NSO. Update and save those changes. And I'll actually publish it down to NSO to the RFS Paris node. So now if I do the show device templates, I see it's in there for me with the variable. Go ahead and delete that change first. I'll remove that so I can apply it through NSO. I'll set my variable. Set that to private with quotes. Pass that in. So you can see here we can either do it from Pronghorn using the netconf API, or we can publish it as a template into NSO as well. Another option here is you can kick off a workflow in case you have some operational controls you want to put around that. That'll just take that and pass it into a workflow with the pre-post checks and so on. So next layer up, we're going to go ahead and get into the services. So if I pop over into Service Manager, same thing like the Device Manager. I can see the list of services that NSO advertises, as well as the list of instances that are associated to it. And back to Chris's reference with the LSA architecture, in this case, we are talking to the CFS layer as opposed to those device interactions where we're talking to the RFS layer. I'm going to jump into our service catalog and request a workflow to be kicked off to provision that port on the LSA CFS node. Of course, this can be done through another system using our API.
and while he's filling that out, if you think back to the smart template example, something Mike mentioned earlier, I just want to make sure we repeat, is that the access to each of these commands is controlled granular through an RBAC and group-based access control that's linked up with your LDAP system. So basically, you can predefine for some of your network engineers a set of templates that they're allowed to use. So when they log in, they only get the subset. And we can control, just like we can with service models, and restrict what parameters by which those people can enter data. So we can do type descriptions, maybe certain lag bundles or certain interfaces always reserved for management traffic. So when we allow somebody to do those, we can restrict, using that template logic on top, we can restrict what APIs each user is allowed to do, as well as what data they're allowed to provide. So it gives you a certain level of control, but also, as you saw, creating them as dynamically as punching in CLI. So you're able to distribute that control out to many more resources within your teams.
So I've clicked into our active jobs, and I can see the job I submitted earlier from the Smart Template application. I'll leave that alone, but I'm going to focus on the port turnup. Start working some of these tasks. This is just a confirmation screen I've added into my workflow. Of course, from the operational model you define within the workflow, it's whichever manual and automated task you want as part of the process. So in here, I started with an initial confirmation. Go ahead and submit it as is. We can see the list of tasks moving along. A lot of these are automated tasks it's performing. If I click into visualize, I can see where it is. Right now it's sitting on the dry run, and of course the dry run in this architecture is going to the CFS node. Some of the other things that have occurred along the way, we've created a change request in ServiceNow. We've done a set of pre-checks using the live exec commands, using the mop template application in Pronghorn. Of course, we're following the green path along here, and for those of you who haven't seen a Pronghorn demo, the green tasks are automated, the blue ones are manual, and of course the red lines are usually a bad thing. So the ones with the dashes are reverting backwards in progress, and the solid lines are going forward. So like I said earlier, this is however you want to incorporate your operational process. In this, I've got a few manual tasks for some demo purposes, and then of course the automated route. So right now the tasks has waiting for us at an approved state. So if I click back into details, I have an opportunity to work that. It's going to prompt up to me, and this is the approved dry run. What we can see here is the changes that were sent to the RFS layer first, which is this XML netconf payload. This is the change that would have to occur from the from the CFS into the RFS. And then what we can see here is the other diff that would occur, which is from the RFS down to the actual device. I'll go ahead and accept those changes. Next task that appears to me is this approved process. And what this is that earlier within the workflow, I created a change request in ServiceNow. So I can go ahead and into our ServiceNow application, look for that change, and work that change there. And got a little ServiceNow set up for demo purposes, so I'll just take a minute here to run through this, and then this will integrate back into Pronghorn and proceed on with the workflow.
A lot of buttons in ServiceNow.
All right, so running through this, got an implement phase here. And what happens, what we've done in ServiceNow is actually gone and implemented our API call to work that task. So even though it was set up in the operational flow as a manual task, there's still an API call behind it. ServiceNow has gone ahead and worked that task, approving it. It's gone through the cycle here, made sure that it was verified. And ServiceNow is an actual state that we could progress on. Otherwise, it would have kicked it out and sent it back to the approved process, approved project. What we've done since is gone ahead and provisioned, it's marked completed, updated the CR, done our post checks, and we're just sitting at a diff screen here. So as mentioned earlier, when we connect into all these different systems, we federate a lot of this data. We don't store it. One of the things that we do store throughout Pronghorn is the auditing controls of what happened. So if I click into, for instance, our dry run, I can see that the incoming payload that was sent into the service, as well as the response that we got back. This is the same thing that we showed in that dry run approval step in more of a JSON native format. We've got the RFS payload as well as the device payload. So from an auditing perspective, all of this is the kind of data that we keep and will be available to you.
Just about on it as far as time goes. So maybe we'll take questions. I don't want to stomp on Stefan's time.
So guys, if
We
you
ran
have
through a
any
lot
questions,
of stuff, so surely it's a question.
raise your hand and we give you a mic.
All super clear?
Hi. I'm just wondering what kind of API you expose. I mean, is it netconf or REST?
So it's mostly RPC. Because we were consuming southbound systems, a lot of times we natively pass similar APIs northbound. So a lot of it's transformed into REST-based calls, but in other cases it's going to be more RPC based. But it's well-documented API that we expose out.
Okay, thanks.
Further questions, guys?
So as part of your example, you were showing the ability to paste CLI config in and help generate templates. What type of strategy do you employ for netconf related devices? Can you still build templates based on netconf devices and that sort of thing?
Yep. So a number of requests into the NSO BU. So those in the room, we can convert basically what the NED supports southbound. So the most classic example is Junos with set commands, and since the NED is netconf based, it accepts netconf versus set commands. So the conversion utility, which is there for convenience, leverages whatever the NED supports.
So for instance, in this Junos template, we've got the CLI, the curly brace notation that Junos supports because the NED will accept that in.
Somebody else? Questions?
Thank you.